Hi, welcome to Tutor Think, and in this video I'll be taking you through the third example under complex numbers. There are a couple of questions that I am solving in series. I have done some previous examples already, but it is very important that you look at the introduction to complex numbers. If you haven't seen these videos, you can locate my playlist Engineering Maths 2, you will find it there. And today we have a set of complex numbers given to us. We are finding its product and how to divide some of them, and we have z1 to be 3 plus 4i, and z2 to be 3 minus 2i, z3 to be 7 plus 4i, z4 to be minus 1 plus 3i. So let's see what we have. In the first question, we are asked to find this. So let's work on the first one. So for this one, we do not have a solution for 2z1 plus 1 and z2 minus 1. So you can substitute the value straightforward to complete the calculation to make it very simple, or you can solve the first bracket, solve the second bracket, and multiply them together to generate the final result. So I think let's do it that way, depending on your choice, what you want. I will use the method of multiplying both I will use the method of solving first and second bracket and then multiply the result together. So first, let's work on 2z1 plus 1. So this is going to give us, what is our z1? So we have z1 to be 3 plus 4i. So we have 2 multiplying 3 plus 4i plus 1. So when we expand this, we are having this time this will give us 6, this time this will give us plus 8i plus 1. So now we have a real term and an imaginary term. This and this will add up. So we are getting 7 plus 8i. So this is the solution for 2z1 plus 1. So let's work on the second one. And we have z2 minus 1. So z2 minus 1 is giving us, what is z2? So when we go there, z2 is 3 minus 2i. So let's put it in. So we have 3 minus 2i and minus 1. So now we just need to subtract this one, and we are having 2 minus 2i. So now we can now pick these two results and multiply it together to complete the calculation. So the two results were 7 plus 8i, 2 minus 2i. So we can multiply the two results to generate the final result. And we have 7 by 2 is giving us 14. We have 7 by 2 minus 14i. And then 8 by 2 is giving us plus 16i. And then this time this is giving us minus 16i squared. But we all know that in complex numbers, I squared means -1. You have to look at the introduction videos. If you haven't seen it, if only this is your first time, then we just need to add all rows and substitute the value of I squared. So since I squared is -1, let's do that substitution. So we have 14 here. This plus this is giving us plus 2i. So we have 2i here, and then we substitute -1 here, times this, we are having minus 16 -1. So this is giving us plus 16. So we are having 14 plus 16 plus 2i. So finally, our result is giving us 30 plus 2i. So the result for 2z1 plus 1, z2 minus 1 is giving us 30 plus 2i. So as you can see, this was very, very simple. So now let's take the second one. Okay, so for the second one, we have z4 plus 4, 1 minus 3z3. So you just substitute the value of z3 and then z4. And we have z3 to be 7 plus 4i and z4 to be minus 1 plus 3i. I think I will challenge you on this one. I will use the same process I went through for the first one and then finish up with this one and see what you get. So I'll give you the possible answer so that you can compare your answer. So finally, when you finish this calculation, you will be having the result to be minus 24 minus 96i. So after finishing this one, this will be your final result. So please compare it very well and check whether I have not made a mistake. So this will be for this example. You can pause the video and finish up this one. So let me take the third example. So for this one, we are dividing z1 over z2, and we know z1 to be 3 plus 4i, and then z2 to be 3 minus 2i. So we have 3 plus 4i dividing 3 minus 2i. So 3 plus 4i dividing 3 minus 2i. Now, you must note that for division, we do what we call rationalization. So we will rationalize the equation and then complete the calculation. And to be able to rationalize, we need to conjugate the denominator by taking the opposite sign of the imaginary term and use it to multiply both the numerator and the same denominator. What this means is that what is the opposite sign? We have a negative here. So when I take the reverse of the negative, will give me positive 2i. So that is the conjugate of the denominator. I will use it to multiply both the top and the down. So let's complete that. So we have 3 plus 4i multiplying. The conjugate of this is 3 plus 2i. And we divide the whole result by this 3 minus 2i, which is this, times the same conjugate, 3 plus 2i. Note that we always take the conjugate of the denominator to do this calculation. So now we can expand the top and expand the down, and then we complete it. So now let's multiply the top and the down. This by this is giving us 9, and this by this we are having plus 6i. 4 by this is giving us plus 12i, and then 4 times 2 is giving us plus 8i squared. Now we divide. So there is I here and I here. That is why we are having I squared here. This by, now we have 3 by 3 is giving us 9. 3 by this is giving us plus 6i. 2 by this minus 6i. And then 2 by this is giving us minus 4i squared. So we can now substitute -1 for all the I squared terms, and we will finish the calculation. So now let's do that. We are having I plus 6i plus 12i. When we substitute -1 here, we are having minus 8, and we divide this by 9 plus 6i minus 6i. When we substitute that, we are having plus 4. So now we can see that this and this can cancel. This will take care of this. We then add this and this, add all reals, add this by that, and then we are done. So we are having 8 minus 9 is giving us 1. 6 plus 12 is giving us plus 18i. And we divide this result by 9 plus 4 is giving us 13. So finally, we can rewrite this by getting, so z1 out of z2 is giving us 1 out of 13 plus 18 out of 13i. So this is our final result for z1 over z2. So for the division, you rationalize the equation by using the denominator, find the conjugate of the denominator, and to find the conjugate, all you need to do is to take the opposite sign of the complex part, and that is very simple. In the final example, we have z2 over 1 plus 3z2. So we can put in the value of z2. So we can put in z2 here to get the equation and use it to do the calculation. So z2 was 3 minus 2i. So we have 3 minus 2i, all dividing 1 plus 3 multiplying 3 minus 2i. So we can simplify this. We have 3 minus 2i dividing 1 plus, this time this is giving us 9 minus 6i. So we can then finally say, so we have 3 minus 2i all out of 10 minus 6i. So now we have the raw equation that we can now rationalize. So to rationalize, we learn that we take the opposite sign of the complex part for the denominator. So now we have 10 minus 6i here. We are using 10 plus 6i to multiply both the numerator and the denominator. So let's complete that. So we are having 3 minus 2i multiplying 10 plus 6i, all divided by 10 minus 6i multiplying 10 plus 6i. So we can complete the calculation by expanding. 3 by 10, we are getting 30. This by this is giving us plus 18i. This by this is giving us minus 20i. And this by this is giving us minus 12i squared. And we divide this by 10 by 10, we are having 100. This by this is giving us plus 60i. This by this minus 60i. And this by this is giving us minus 36i squared. So we all know this is neg1. We can substitute that. So we have this and this. We are having 30 minus 2i minus 20i. Okay, so plus 18i. Then when we substitute negative 1 here, we have plus 12. We divide this by 100 plus 60i minus 60i. When we substitute negative 1 here, we have plus 36. So now we know this will now cancel this. We can add this to give us minus 2i. So we are having 30 plus 12 is giving us 42. We have 42, and we add this and this minus 2i. And we divide this result by 36 and plus 100 will give us 136. So this is giving us 42 out of 136 minus 2i out of 136. We can break this down with 2. Yeah. So finally, when we break this down with 2, we are having 21 over 68 and 1 out of 68. So our z2 over 1 plus 3z2 is giving us 21 all over 68 minus 1 over 68i. So now know that 2 will cancel. 2 into this is 1, 68. 2 into this is 21, and 2 here is 68. So this is the result for 2 over 1 plus 3z2. I would give you 2 different examples for you to do on your own so that you can practice on that, and I'll give you the possible answers for you to cross-check. Okay, so you'll be solving z2 over z1, z4 plus 2 over z1 minus 2i. These are z1, z2, and z4. So I'll give you the possible answers. This one will give you, this one will give you 1 out of 25 minus 18i out of 25. So you cross-check that, and this one will also be 9 out of 13 plus 7i out of 13. You can pause this video, make sure you go over these two to equip yourself, and I hope this was very helpful. Thank you. I'll end it here. My name is Daniel, and I hope to meet you here the next time.